question is the field connection in quantum non-locality in Bell's theorem and the Einstein-Rosen-Podolsky paradox, that kind of quantum non-locality, related to morphic resonance? Are they two aspects of the same phenomenon? That's the really interesting question in relation to existing physics. And nobody knows the answer. I don't know how morphic resonance as conceived would fit with quantum non-locality, which, although it does in fact involve a past, because both systems originate from a past, and it's to do with a system with a past, which is, I would say, the very existence of these particles is a kind of resonance from their own past. And I would say that there is a kind of morphic resonance link, and probably that's what it might be. But I can't fit that into the formalism of quantum theory, because I don't know it. I'm not a quantum theorist, and to work with those equations with any degree of subtlety would require a deep understanding of the subject. On the other hand, J.S. Bell, the inventor of Bell's theorem, has been in correspondence with me. He's read both my books and has sent me his latest book. So we've been in a correspondence about the possible connection between morphic resonance and his own theory. He's perfectly intrigued by morphic resonance and morphogenetic fields. And he thinks they may be connected with his own theory, but he can't see how, because there's nothing in the conventional physics which has yet proved, because it's so based on eternal equations. The idea of Schrödinger's equation is a kind of eternal Platonic form that governs all quantum processes from the beginning of the universe to the end in exactly the same way. That's the kind of inherited formalism of quantum mechanics, and that kind of mathematics, which postulates eternal Platonic type forms, is not going to be adequate for modeling an evolutionary universe. And so it's not clear how the bridge can be made, or even whether that connection, but I think there must be some kind of connection. There can't be lots of totally unconnected types of non-locality in the universe.
Rupert, why not replace the Platonic models with fractal models, and then say that time itself is the morphogenetic field? That it is some kind of fractal topological manifold and so the repetition or the connection to past states is really accomplished through resonance within the fractal, and then we have a model for resonance because it's familiar to us from other domains of nature.
Well, I don't see quite how there's a sense in which the fractal is a new mathematical model that gives us the same idea, that the ancient idea of the microcosm mirroring the macrocosm, the idea of different levels.
Well, but not only different levels, but different points on the same level, in the same way that the past occupies a relationship to the future of formative anticipation, so in a fractal do early portions of it anticipate later forms. So it is like a prediction, a self-fulfilling prediction is what a fractal is. It predicts by virtue of its past states. They define what its future states will be, exactly in the same way that I imagine the morphogenetic field defines what future states will be. The fractals that have been talked about to date have been used to describe spatial phenomena, coastlines, molecular arrangements, distribution of flowers in a meadow, this sort of thing. But if instead you thought of fractals as descriptors for the temporal dimension and replace the notion of a flat or slightly curved manifold with an actual fractal surface over which events were flowing, and flowing over patterns which repeated themselves at many, many levels in resonance with previous similar patterns, then you would begin to have a mathematical picture of how the morphogenetic field would work, and you would also have found a phenomenon in nature upon which to hang it by saying time is obviously it. It's just that we are so ingrained by Newtonianism to accept time as an abstraction, as something not having equal status with the other three dimensions, that we've overlooked this fact. And yet, obviously, that is the carrier wave. That's why you would speak of the presence of the past. What then can it be but time, past time in the present?
Well, it is past time in the present. But the fractal wave, you see, why I don't like the fractal model taken to any great extreme is because any kind of mathematical modeling, given the whole nature of mathematics as it's practiced, fractal mathematics is conventional paradigm in the sense that you create an equation and you generate this form. The equation itself is not subject, the governing equation is not subject to evolution. It's generating the same form, and it would go on generating the same form right into the future. In other words, it would be a kind of determinism based on a kind of Platonic or Pythagorean ideal form, the fractal equation, which generates the fractal. And I don't understand evolution as happening like that. I don't think it's as deterministic.
Well, you're right, that as they are presently understood, it would generate, however complicated, ultimately a determinism. But I wonder if we're just not mathematically sophisticated enough to inculcate into the fractal equations sufficient randomness within the fractal constraints to begin to get the kind of complexity that we meet in the real world.